So, good day, grade 8 Makati Science High School students. Okay, for our lesson for today, we're going to be discussing the fifth module, okay, or the fifth lesson, okay, regarding the segments of a circle that we can find in a circle, and that will be the chords. Okay, so if we have a part of a circle, we know the secant line goes beyond the circumference. We know that the tangent line passes the circle at only what point, and the chord, okay, kind of like a diameter, but not necessarily restricted to being found in the center of the circle. It's a line segment that connects 2 points on the circumference of the circle. And this is what we're going to be discussing about and what we're going to focus on. Okay, so let's try this first problem. Juliana is curious how long are the roads at an intersection in their barangay, given the circular area zoning of the roads of the intersections. With the rough outline of the intersections reflected below, if HP, okay, this line segment over here is equal to 6 km, and PJ, okay, wait a minute, HP, yeah, and PJ is equal to 4 kilometers. Okay, so this one, okay, so this is point B. Yeah, so PJ is equal to 4 kilometers. And LM, okay, this entire length here is going to be equal to 11 kilometers. What are the measurements of LP of this road intersection here and this segment right here? So the measurement of the entire chord LM. So how are we going to solve this problem? We're going to use the We're going to use the chord power theorem. And what does the chord power theorem state? Okay, so it means that, let's say for example we have here this figure. It states that if you have here one chord, okay, so the segments of the chord here for LM, okay, they should be equal to each other or directly proportional to each other. So therefore this is gonna be the segments LP. Okay, so this is LP for this one. This is point P at the center. Okay, so this is gonna be LP times MP. Okay, so that's gonna be equal to HP times JP or PJ. Okay, for this problem. So let's write that formula over here. So that's LP times MP is going to be equal to HP. Okay, so it's equal to HP times JP. It all stems from the center there. Okay, and let's say for example, okay, we have here the value for HP, so that's equal to 6. And we have the value here for JP or PJ, so that's equal to 4. So that should be equal to the length of LP. Okay, so LP here, guys, if you look at here at LP, okay, this is line LP, okay, and it's missing. Okay, so for this problem, since we know that LM, the entire line segment LM is equal to 11, we can say that LP, okay, LP could be X, okay, X for this one, and MP over here, this line segment here, could be 11 minus X. Since LP is just a part, it's just a part of the entire thing, which is LM. And therefore, we have here a quadratic equation that we can solve for this problem. We can distribute x here, so that's going to give us 11x minus x squared is equal to 24. Okay, and then if we're going to create a quadratic equation for this one, so this is going to be equal to 0. Okay, 0 is equal to x squared minus 11x plus 24. Okay, and if we factor x squared minus 11x plus 24, we can get that the value of the two x's that we have here could be, okay, negative 8 and then negative 3 for this one. So x minus 8 times x minus 3. Because negative 8 times x will give you negative 8x, okay? And negative 3 times x will give you negative 3x. And if you add negative 8x and negative 3x, you're going to get negative 11x, okay, for that one. So therefore, we have two values. X sub 1 is going to be equal to 8, and x sub 2 is going to be equal to 3. Okay, so for this example, since we know Okay, we have here the values, the two values of the chord. That's gonna be 8 and 3. Okay, so they have to be the same to each other. Okay, so if we're going to plot this, okay, if we're going to create the equation over here, so that's gonna be x times 11 minus x is gonna be equal to 24. Okay, let's try the value of 8 if it will give us 24. Okay, so that's gonna be 8 times 11 minus 8. So it's 11 minus 8. Okay, 6, 7, 8. So that should give us 8 times 3. Okay, so that gives us 24. Okay, for this one. And let's try if it's equal to 3. Okay, so if this is 3 times 11 minus 8, okay, so that should give us 24. Okay, and therefore this is going to be 3. Okay, and 11 minus 3, so that should give us 8. And that's also going to give us 24 for that one. Okay, for this one, since we know that this is going to be equal to 10, and this is going to be equal to 11, okay, what are the measurements of LP and PM for this one? So since this is LP, okay, so it has to be directly proportional to this one, to this part. Okay, to PJ, and PJ or JP is just equal to 4. So therefore, the best value that we have based on this diagram would be equal to 3. The value of LP should be equal to 3 if we're going to consider the diagram that we drew here, if it's going to be proportional based on the chords that we drew here. So LP should be equal to 3 kilometers, and therefore, the measurement of LM, okay, the entire of the entire road is just going to be 11 kilometers, which is our given. And we can also solve for the side measurement of PM if it's going to be continuously proportional to each other. So that should be 8 kilometers. Yeah, for this one. So therefore, we're going to take the value of x sub 2, which is equal to 3. Both of them give valid solutions, but the best one, using this diagram to keep the segments proportional to each other, would be 3 kilometers. Okay, and that's how we solved this problem for chord power theorem.